All right, hello guys and gals. Welcome to day 2 of Unit 5, Direct Variation. You are going to need out a pencil and your packet. Feel free to pause the video whenever you need to or fast forward it if you feel like you know what you're doing. Just keep in mind I will check your guided notes as well as the practice problems to make sure you're getting the hang of it when you come to class on Tuesday. So here we go. I'm going to have you start with a warm-up just to make sure you understood Monday's assignment or Monday's lesson on direct variation, because today we're going to talk about a different kind of variation. So I want to make sure you have straight in your mind what direct variation is so that we can move on. So take a couple of minutes to do this warm-up. It should be located right after homework number 1 in your packet. Pause the video until you're done, and when you come back, I'll have the answers up for you. All right, here we go. Direct variation is a special relationship in which there is a constant ratio of y to x, or y over x, between all ordered pairs. The equation is always in the form y equals kx, where k is your constant. B will always be equal to 0. So if you're thinking back to linear equations where we have y equals mx plus b, b is always equal to 0, which means you are always going to have a straight line that goes through the origin. 0, 0 will always be an ordered pair if the equation is direct variation. To identify the constant and equation of the ordered pairs below, remember you're taking a look at the relationship between y and x, and basically you're kind of trying to figure out what happens to x in order to get to y. How is my input affecting my output? And so in this case, I take a look and I see that the ratio is always 1/2. So therefore that leads me to the equation y equals 1/2 x. Letters A and C are representative of direct variation because I can easily pick out the constant in each. In this case, for letter A, the constant is 4. And C looks a little deceiving at first, but remember you need to be thinking, you need to be thinking about if there's any way you can manipulate an equation to get it into the form y equals kx, then it is considered direct variation. So I did that here and I found that my constant was positive 1/3, y equals 1/3 x. Direct variation will always pass through the point 0, 0. And if we're trying to find a missing value in an ordered pair that we know is direct variation, we can set up a proportion where two ratios are equivalent to each other. When you have two ratios that are equivalent to each other, you know that the cross products are always going to be equivalent. And so I just cross multiplied and then did a little algebra to solve for x, which equals 14. So that is direct variation in a nutshell. Let's move on to inverse variation. So inverse variation is another kind of specific relationship, but this time there is a constant product. I don't know if I gave a shout out to Natalie Marcel. She gave me this new stylus that she found at her house, and it's working much better than my last one, so thank you, Natalie Marcel. The product that we're really taking a look at in terms of an ordered pair is x times y. So we're looking at the x value and the y value, and we're noticing that when you multiply them together, they will always have the same product. The equation for inverse variation looks a little bit different than the direct variation equation. Excuse me. And it's going to be y equals k divided by x. And if I do just a little quick algebra here, I can multiply both sides by x, and I find that to isolate the constant, or to figure out what the constant is, what I'm really doing is multiplying the x value times the y value. This will make a little more sense when we do some examples. So let's find the constant. It says identify the constant of the ordered pairs below, then write the equation to represent the relationship. So again, yesterday for direct variation, we were looking at y compared to x, but we were looking to see if there was a constant ratio, that division happening. Today we're going to be looking at y and x, but this time we're actually going to be multiplying the two. And we're going to see whether or not there's a consistent relationship between the input and output. When I multiply my input with my output, do I get the same product? And here you notice that each time I get 20, and that's how easy it is to find the constant for inverse variation. Same thing for number 2. I notice that each one of these ordered pairs has a product of negative 28. So therefore, we can be sure that this is inverse variation, and we can find our constant is negative 28. Go ahead and pause the video, do numbers 3 and 4, come back when you want the answer. Alright, you should have gotten a constant of negative 12 and a constant of positive 6 for numbers 3 and 4. And now I'm going to go back because we also need to write the equation to represent the relationship. So I'm going to give myself some more space here. Maybe. And I'm going to write the equation for each one of these. So I know that the constant for this one was 20. I also know that the equation is going to be in the form y equals the constant k over x. And so there's my equation. Here the constant was negative 28. So the equation that represents this relationship is y equals negative 28 divided by x. And just to make sure, if I were to plug in one of my x values here to the equation, do I get the output of y, negative 28 divided by 2? Yep, I get negative 14, so I know that I've got it set up correctly. Constant was negative 12. Constant was positive 6. And now I've got a generic relationship, a generic equation that represents this relationship. Pretty simple. How about when it comes to graphing the inverse variations? Yesterday when we talked about direct variation, we talked about the graph always going to be linear, and it's always going to pass through the ordered pair 0, 0. So that's sort of the two giveaways for direct variation. I'm sorry. For inverse variation, it looks a little bit different, and I want you to sort of figure out what this graph is going to look like. This example says, if the constant of an inverse variation is 16, create a table of values to graph the relationship. So what we're looking for here is the constant of variation. The constant of variation, which here says it's 16, and it tells me to create a table of values. So that's just a simple input-output table. And you really have the freedom or the control to decide which values you want to plug in for your input or your output. All I really know here is that whatever happens, I know that the product of x and y has to be equal to 16. So for example, if I plug in 1, there's only one possible output that y could be. If I take a look in terms of the equation, y is equal to 16 divided by 1, for example, because that's the input that I chose, so y equals 16. If I want to know what is the output when the input is 2, I plug in y equals 16 over 2. When x is 2, y is 8. Now if I chose 3 as a value I wanted to input, y equals 16 over 3. I don't get a nice neat whole number, so I might not use that for one of my x values. Oops. There we go. Yikes. 4 is a value that would work out pretty nicely. And notice that each of these has a product of 16. something I want you to think about is what would happen if I were to plug in 0 as my x value. Would this graph, would this equation have an ordered pair of 0, 0, like the direct variation equations did? I'm not going to tell you the answer, but I think that you can discover it on your own. If you plug in 0 as your x value, would you get 0 as an output? I want you to pause the video for a minute, and I want you to actually come up with like 6 to 8 more ordered pairs that you can use to plot this graph. Because with inverse variation, you can't really tell what the graph is going to look like if you only have a few points. And so I want you to come up with between, 8 and 10 points that you can plot on this graph to really get a good idea of what the relationship looks like in terms of a graph. And I will give you a hint, it is not linear. So pause the video, keep this table going. You can pick any values that you want to, just make sure they'll fit on your graph. So positive or negative x values, and I'll give you a minute or so to do that. Plot the points and take a look at the graph when you are finished. So here are the values that I used. Notice I chose some positive values for x and some negative values for x, and that gave me a really good representation of what this relationship looks like. Math is all about patterns, guys and gals, so direct variation will always be a straight line that goes through 0 anytime you have an equation y equals kx. Inverse variation will always provide a graph that looks like this when you plot the points. Oh my goodness, Noah got me sick this weekend. Oops, sorry. And that question that I asked about, will we go through the origin? The answer is no. And that makes sense when you think about it, because if you have 0 as your input, there's nothing that you could multiply 0 by to get a product of anything other than 0. So we could never have 0 times 0 equals 16, or 0 times 0 equals 32, or whatever the constant of variation is. So 0, 0 will not be a point in inverse variation. I want you to try numbers 5 and 6 on your own, so pause the video again, create your own table of values, plot them on the coordinate grid, and then come back when you're done. Here's what you should have got for numbers 5 and 6. You may not have chosen the exact values that I did, however, our graphs should still look the same. All right, we got one more thing in this lesson, and that is how do you find a missing value? And really, there's not a whole lot to it if you understand that the product of x and y is always going to be equivalent in inverse variation. So if I know that these ordered pairs will both have the same product, I can really easily find a missing value. If I multiply 12 and 14, I get 168. So that has to also be true for multiplying this next ordered pair, negative 24 times y. Because we know that this is inverse variation, so we know that their products of x and y have to be the same. And so I can just do some simple algebra to solve, and I get negative 7 for y. I'll do one more with you. X times y equals negative 60, which has to be equivalent to this product, which will also be 60. So to solve for y, I divide by 3, and I get negative 20. Pause the video, finish this off, and come back to check to make sure you're on the right track. Questions, make sure you're jotting them down. I hope that this went smoothly for you and that you're feeling pretty good about inverse variation. If not, we will address your questions tomorrow. Have a great night. See you in class.